Hello, my name is Cary Jensen, and welcome to CodeRage 2018. This session is Persisting FireDAC Datasets to there and back. Let me share some information about me. I'm Chief Technology Officer at Jensen Data Systems with more than 30 years of experience as a developer, consultant, trainer, and mentor. I've written more than 25 books on software, including my latest book, Delphi in Depth FireDAC. I specialize in database development, application architecture, and component development, and I'm an Embarcadero MVP. I also have a PhD in engineering psychology from Rice University in Houston, Texas. You'll see here on this page also my contact information. Here are the topics I'm going to cover in this session. I'll begin with a broad overview of FireDAC. Then I'll discuss what do I mean by persistence. Next, we'll look at persistence in FireDAC, including saving to files and saving to streams. I'll also discuss what can be saved when we persist data. Next, we'll look at restoring previously persisted data, including the merging of data. Finally, I'll conclude with automatic persistence and how that can be used to create backups. FireDAC is a comprehensive, component-based data access framework available in Delphi. It represents the most complete support for the T-Dataset API, the application programming interface for data access in Delphi. FireDAC supports a large set of database servers and data formats, and it provides a smooth migration path for legacy applications, particularly those that were based on the Borland database engine. In all, FireDAC supports an unmatched collection of capabilities. It has become the preferred data access framework for data access in Delphi. So what is persistence? Persistence refers to the ability to save data at one point in time, preserving the opportunity to restore that data to its original state at some later point in time. This data can be saved to a physical file, or it can be saved to a stream. When it's saved to a stream, that stream can be transmitted over a network, or even saved in a blob field of a database. Upon restoration, the restored data may be indistinguishable from that which was originally saved. In FireDAC, persistence is a capability of all FireDAC datasets. Prior to FireDAC, only the client dataset could be used to persist data. But with FireDAC, your FD queries, FD stored procedures, and FD tables can be persisted as well. It's not just a feature of the FD mem tables, although FD mem tables do support persistence. Because the datasets in FireDAC support persistence, this greatly decreases the need for FD mem tables. Of course, FD mem tables have their own set of capabilities that are very valuable, and you may want to use them in your application, but you don't have to use them just because you want to have persistence. Let's consider saving to files. With a FireDAC dataset, you save to a file by calling the SaveToFile method. That method takes 0, 1, or 2 parameters. The first parameter is the file name. Now this is interesting because the file name can include some very specific substitution variables in the file name, including $doc, $temp, $run, $rand, and $next. These substitution variables get expanded prior to saving the file. $doc represents the documents folder in your Windows installation. $temp is a temporary directory and expands to that folder. $run represents the directory in which your executable is stored. $rand is a random integer as a string. And $next is used to generate the next integer in a sequence. And you can use these substitution variables in various parts of the file name. So for example, if you want to store the file in the directory where your execution is stored, you would begin your file name with $run. and then follow it with a slash and then the name of the file. That file could include something to the order of backup $next. Of course, after the $next, you would include a dot and a file extension. Although you can omit that in various scenarios, and I'll talk about those a little bit later. In addition to these 5 substitution variables, you can also include your own environment variables in the file name. And you do that by doing $open paren and then the name of the environment variable. And that environment variable may be a string or it could be a folder path. If you call SaveToFile with no parameters, then you must have defined the persistent file name in your resource options. And we'll come back to that later when we talk about automatic persistence. If you do include a file name, you have the option of including a second parameter, which is the supported file format. Specifically, one of the values of TFD storage, which is a set. And those include SFXML, FSJSON, FSBinary, and FSAuto. Of course, this is how you can specify that you want a particular file format saved. XML clearly will create an XML file, JSON will create a JSON file, and binary will create a file that is specific to FireDAC. Finally, there is a Save Pretty option. In the resource options for your FireDAC dataset, there is a property called Save Pretty Print. And if you set that to true and you are using an XML or JSON format, FireDAC is going to format the data to be more human readable. It'll put lots of carriage returns in and it'll use indentation to make the text very, very readable. So let's go ahead and take a look at this. I have an example project that you can download. It is called FireDAC Save and Load, or FDSaveLoad. Now this has, I have a couple data sets here. These are FDMEM tables that contain customer data and employee data, and I'm using local SQL to query them. So here's an example of a query. I have a little note up here. There are only 2 tables available to query in this database. And let's go ahead and run this project. And we'll run the query, and when I call save to file, I'm going to be saving the file from this result set here. And when I say save to file, I'll go ahead and specify. Okay, let's go over to CodeRage and persisting data and save and load. And here I'm going to enter CA customers for California customers .xml, and we'll save this as XML. Let's go ahead and take a look at that file that we just created. And here, CodeRage. And CA customers XML, and I'm going to open this with Notepad. Otherwise, if I open it in Internet Explorer would format it for me, and I don't want that. I want to show what it looks like. So this is not a very human readable form, but it is terse. It doesn't have the extra carriage returns, and it is in fact valid XML. Let's save this again, but let's enable the pretty print capability. And we got this CA customers. I don't need all of that, but I will say I'll call this CA customers pretty. And now we'll go down and look at CA customers pretty. And we'll see that it's formatted. Let me turn off the word wrap, and we get a nice, much more human-friendly format of this data. Let's try the JSON. This time I will leave pretty print on, save to file, and we'll say CA pretty, except I'll change the extension to JSON, and we'll go and look at this. CA pretty JSON. Oh, open with. Okay, I guess I haven't opened on this particular one. I haven't opened up JSON yet, and Word. Well, I'll use WordPad, and I'm disappointed it's not letting me do this in Notepad. Okay, and there we have it. There's our JSON for all those records that were stored there. Okay, so let's just take a look at this code. It's here. Okay, we open Save File dialog box, and we're in this case I'm actually using two parameters. The file name I've selected, and I'm using specifically specifying fsxml. If I used fsauto, I'm pretty certain I would have gotten exactly the same results because of the file extension I used, but in this case I was being very explicit about it. If we look at the code associated with the checkbox on save using pretty print, you'll see that I'm just really toggling the store pretty print of the FD query's resource options. The resource options of the FireDAC query allow me to set the resource options directly for that FireDAC query. Alternatively, I could have set that store pretty print resource option for the connection that this FireDAC query used, and any other query that also used that same connection would be storing pretty print as well. On the other hand, I could have even gone one level up and set the store pretty print property of the FD Manager, and then all connections and all queries and stored procedures and tables would by default store pretty print, although you can override those on specific FD tables or FD queries by going into their resource options and changing their store pretty print parameter. I will show you an example later on of using substitution variables, so we will come back to that. Saving to streams. You save to a stream by calling SaveToStream, and when you do so, you pass either one or two parameters. The first parameter is a tstream, and in my example, I'm going to use a tmemory stream. If you want to include the second parameter, you're including a value of the type tfdstorage format. And again, this allows you to specify specifically the storage format that you want to store that stream in. You could just simply use auto. I found in a couple situations that I want to explicitly store it in a given format, and then when I load it again later, I want to tell it it's this format. So let's go ahead and look at Delphi and see what this looks like. So I've got that application running. Now, this is not so very visual when I save to a stream, because I'm going to do something that I find very useful. I had mentioned in the slide that when we save to a stream, we can then take that stream and transmit it across the internet, but we can also save it into a blob field in a database. And in this particular case, I'm going to do just that. However, this is a temporary database that's created every time I run this application, because I am using the FD local SQL. So I'm using SQL based on the SQLite definition of SQL, and that is we see we have a SQLite FD connection component here. And so notice what I do when I click Save to Stream. I am actually asking for a dataset name, and that's really going to be the name that I'm going to store this file under, actually the stream under, within my database. And so what I do here is I first call FD SaveToStream, and I'm saving it to a memory stream that I create here. And I'm saving it in XML format, rewinding the memory stream to position 0, and then I am opening a query selecting all the data sets from from our database that we're connected to, which is basically a virtual database in memory. And then as long as I have data in my query, I'm taking the database name that was entered in that input query, and I'm assigning it to the first field. And then I'm loading the second field, which is a blob field, from that stream. And that's how I get the data in there. Now you may be wondering, where did this data table come from? And we'll see that over on the form create. When the form starts, I start a transaction and create a table called data store tab, but that's the constant. It's actually called stored data sets or stored data sets. And I do that, and then I set some settings. But the most important thing is that database that I'm writing to, and that particular table I'm writing to, is created when this form is initially loaded. And then just to remind you, we're then selecting records from that data set. And I could have actually done this slightly differently. What I could have done was to create an insert query. But in the way I did this here, by opening a FireDAC query with all of the records, I then could call append, which added an additional record, and then I'm loading the data into that record and posting it. What gets persisted? Well, the really cool thing about this is that you get to choose what gets persisted. You can choose to persist one or more of these following characteristics. You can choose to persist the data that's stored in the FireDAC dataset. If you've been using cached updates, you can also store the changelog, or you can suppress the changelog. You get to choose whether you store the metadata or not. And the metadata is a description of the structure of the table that you're storing. This last one is kind of an odd one. It's you get to choose whether or not to store the visible records, and that is there is a property in FD datasets called filter changes, and you can set it to include unmodified records, modified records, inserted records, and deleted records. And visible records is going to base the records that it stores on that filter changes property of your data set. So for instance, and this is pretty interesting, I could filter my FD dataset on my deleted records. This assumes that I'm in a cached update mode and have captured deletions and cached them. Then I could say I want to store the visible records, and I could actually store off a set of the records that were deleted so that at some later time I could go retrieve them if that was something that I needed to do. So let's go ahead and look at the, I'll just bring up Delphi here so that the whole project is available. Go and look at what I've implemented here. So for the save options, I've allowed you to checkbox data, delta, metadata, and physical. And if you, let's look at the data and look at the click event handler there. And it's basically saying, look, if you have checked this, then we're going to make sure that the SI data flag is in the resource options store items property. If it's not checked, then we remove the SI data. And the same thing is true for the others. So the data, the delta, the metadata, and the visible. The default property for the store items is SA data, SA delta, and SI metadata, which means that you're going to store all the information you have about the data, the current state of the data, and if cached updates were used and you have a changelog for the FireDAC dataset, it's also going to store the changelog as well. So let me demonstrate this. Now, in order to do this properly, if we want to see the metadata, if we want to see delta, we have to be in a cached updates mode. So I have this data set here, and I'll enable cached updates. And let's go ahead and delete a couple records. I'm going to change American Scuba Supply to American Scuba Company, and let's go ahead and add a record too. We'll call this Cary's Dive School and post that. And so let's go ahead. I have data, delta, and metadata. Oh, and let's turn pretty print on just to so that it. Okay, let's save the file and file name. Let's just do file name test.xml, and let's go ahead and look at it. Okay, so here's our metadata there, and here is our data, and notice it has identified 2 deleted records, and here is a modified record. Here's the original and there's the current, and then down here we have an inserted record. So this inserted, modified, and deleted, that's able to restore the cached updates information. This information here is used to identify the metadata, the structure of the file, and of course all the original values are the values that will be present if we cancel the cached updates. Let's go back and see how this can be used. So let's close that. Let me rerun the query against the data set. Oh, let's say, oh, it doesn't matter. I think I just run that query. No, it says that it's been, so I have to cancel updates. I will rerun the query, and there's our data. Now let's load from file, and we'll load up the text.xml, and now notice we are in updates, and notice that there is cached updates there. The 2 records that were deleted are there. The change that we made and the addition that we made is here, and this is actually in a cached update state. If I press apply updates, that data will be written down to my database file. Frankly, I don't want to do that right now, but in a lot of cases when you're doing persistence, that's exactly what you want to do. You're persisting data off. Maybe you're using a briefcase model of your application. Every time you persist, if you're in cached updates, you want that delta information to be stored in the persisted file. This will allow a user to make some changes over multiple sessions. Possibly they have retrieved data from a database server, but then gone out into the field where there's no wireless connection, or there's no ability to connect via mobile phone, and they make a bunch of changes but close the application and open it, close it, open it, and make multiple changes over multiple sessions. Now they're back at the office. They load up again, and it's got all these cached updates. You're able to connect to your database, and here you're doing the apply updates. So really nice feature. All right, let's continue now. Restoring persisted data. You restore persisted data by calling load from file or load from stream, depending on how you persisted the file. When you call load from file, you can provide 0, 1, or 2 parameters. If you have no parameters, then it's resource option settings that are going to control what file gets loaded and what format is being loaded. If you provide 1 parameter, you're specifying the file name. And that file name can use those substitution variables that I introduced earlier. If you provide 3 parameters, you're providing, if you provide 2 parameters, you're providing the file name and the file format that you are instructing FireDAC to restore from. Loads from stream is very similar. You provide a call to load from stream, and you provide it the stream in which the contents is provided. and you have an optional second parameter which will be the file format. And in the work I've done, I've often found that, and I mentioned this earlier, that when I save to a stream, I will save to a specific file format, and I'll specify that same file format when I load from that stream. Now here's the really, really cool and rather complicated, interesting bit about loading data into a data set from a persisted file or a persisted stream. You can merge data from more than one file or more than one stream. Now that might sound very unusual because if you're a longtime Delphi guy like me, you're familiar with load from file in a client data set. And when you do load from file, if that client data set already has data in it, it's going to be purged first, and then the new data will replace whatever was in there. But with FireDAC, you can do some really interesting things because you can have data in a FireDAC data set and then call load from file and bring data in that doesn't necessarily replace what's already in there. It can add to it. That is done through the store merge data property of the resource options associated with your FireDAC dataset. And store merge data is of type TFD merge data mode, and it includes 7 different settings. When store merge meta is set to DM none, the default, no merging takes place, and the FireDAC dataset is loaded with the contents of the file or stream. The remaining 6 possible values of store merge metadata are organized into 2 sets of 3, with one set applying to the data and the second set applying to the change cache. Let's consider the set that applies to data first, and these values are DM dataset, DM data append, and DM data merge. For these values, the data that is being loaded will either replace the data in the active dataset, as in DM dataset, be added to the dataset in the active dataset, DM data append, or be merged with the data in the active dataset. For the set of values associated with the change cache, delta, essentially the same rules apply. When store merge data is set to DM delta set, any data and change cache information in the active dataset is replaced by any data and change cache information being loaded. A value of DM delta append causes any data and change cache information being loaded that is not already in the active dataset to be added to the active dataset's data and change cache. Finally, merge will either update or append the data and change cache of the active dataset based on the data and change cache that is being loaded. With the resource options store merge meta, this controls how metadata is merged in when you have an active data set and you're moving data into it from another file or stream. When store meta merge is set to none, the dataset returns its original metadata regardless of the contents of the data being loaded. If the structures of the dataset and that of the file being loaded match, everything's fine. If there are discrepancies, data will be loaded into the dataset using the rules defined by store merge data, only for those fields in the structures that match. For example, if the active dataset includes string fields named first and second, and the data being loaded defines fields named first and last, data will only be loaded into the dataset's first field. When store merge meta is set to none, it is necessary that the FireDAC dataset into which the data is being loaded has metadata, or that its potential metadata can be discovered. When store merge meta is set to merge, columns from the dataset being loaded will update the dataset doing the loading. When matching column names are found, any differences in those columns' type and size will be updated in the loading dataset to match those of the values in the dataset being loaded. If columns are found in the dataset being loaded that do not match those in the dataset doing the loading, those columns are added. If store merge meta is set to add, any column found in the dataset being loaded that is not already present in the dataset doing the loading will be added. Columns with the same names are unaffected in the dataset doing the loading. Assigning update to the store merge meta property will result in matching column names being updated in the dataset doing the loading, based on the metadata found in the dataset being loaded. Column names found in the dataset being loaded that are not present in the dataset doing the loading are ignored. When store merge meta is set to add or error, one of two things will happen. If the dataset doing the loading has no metadata, the metadata found in the dataset being loaded will be used. If the dataset doing the loading has metadata, it must match that of the dataset being loaded by name, type, and size. Otherwise, an exception is raised. The final store merge meta value, error, requires that the dataset doing the loading has metadata, and that it matches the metadata of the dataset being loaded. If there is a mismatch on column names, types, or sizes, an exception is raised. Clearly, these are complicated settings. What you can do in Delphi, if you want to play with this, a reasonable thing to do, I'm going to hit cancel updates here, and let's go ahead and just one more time I'm going to save this to a file, and I'll say this is CAREX for California records.xml, and now I'll run the query, and this time I'll select customers from Hawaii, where it's HI is the abbreviation. Run query, and I will say saved file, and instead of CAREX I'll say HIREX. And now I'm going to say that I want to store merge data, and I'm going to append, and I'm going to load from file, and I'll get the HIREX, and that data gets loaded in. If you have different columns of the data you select in your query, or you do some changes and apply those changes so that you have key fields, which is the customer number, but some of the data is different, you can test out how the store merge data works. If you have different numbers of columns, you can play with the store merge meta, and this allows you to really investigate the finer features of this particular these particular features. Okay, now this takes us to the final topic, which is automatic persistence. Now this is a very, very cool thing, and it really applies in two specific scenarios. First of all, if you want to build an application that has relatively simple data management needs, it just needs to be able to save to a file, and then when you start up the application, load from that file and keep the data over an extended period of time, but storing it in a file instead of a database. For example, in a simple address book type application, you can configure FireDAC so that when you open your data set, it loads with data, and when you close the application, it saves the data. And you don't need to use code. The operation occurs in the background automatically for you. The second application of this is the ability to create a backup file so that users can make some changes and save and close their application, and after they've made changes to their data, a backup is created. So you always have at least the image of what the data looked like the last time it was edited. And you can get pretty sophisticated with this by using the $next substitution variable, and then you can create multiple backups. For instance, you'd have the backup 1, backup 2, backup 3, backup 4, with the higher number always being the most current backup. Now you have to be careful there because you're storing multiple files, and after a while you're going to have more backups than you want or need, so you're going to have to build some additional logic into your application to ensure that you're only keeping so many backups. Nonetheless, this can all happen, and it happens through the use of resource options. Now, I referred to resource options multiple times, but there's actually two resource options classes that you have. In the FD connection and FD manager classes, their resource options type is FD top resource options. In the individual FireDAC datasets, such as FD query and FD table and FD memtable, the resource options property is type FD bottom resource options. What this really means is to really take control over these features and these examples that I've used of the having a automatically loading and saving file format, or having the backups being created, you're going to use a combination of the FD datasets resource options and its the object that it inherits from, the FD connection or FD manager. If you're creating backup files, you would specify the folder and the file extension, the default folder and file extension for that backup file using the FD connection or FD manager. You then, if you are using a persistent file in which you are automatically loading and saving a file, then you would specify in the FD connection or FD manager the default store folder. Anytime we're talking about folders, you can use variables. So the backup folder, I didn't put that here, but you can use variables there. And I'm talking about the substitution variables and the environment variables. If you're creating a backup, then you set the backup resource option to true, and that's in your FireDAC dataset. The default store extension is also in the default dataset. Persistent means that you want to automatically load and save a file. That's a Boolean property, and you set it to true if you want to persist your file. And then the persistent file name is the name of the file that you want to write to within the default store folder. And that file name, if you don't have default store folder, you can actually put a full file name there. And again, persistent file name can use variables. The load from file at open and save to file at close are functions that you can use to programmatically determine whether automatic loading and saving is occurring. And so it's not something you set, it's something you read, and that'll allow you to determine how things are being done. So let's go back over to Delphi, and I'm going to open up the next example project. The final example in this session, in fact. And I'm going to open up, okay, so this is the Autoload backup. Now I'm using a FireDAC memtable in this particular example. The interesting thing about FireDAC memtables is it's the one data set that doesn't have an FD connection, because clearly there's no connection to a database associated with the FireDAC memtable. In that case, if I want to work with FD top resource options, I have to work with the FireDAC Manager, FD Manager. Now there's a default one. This is a singleton object, and you can only have one. And if you don't actually place an FD Manager into your project, one is created for you. And that's the thing that's the version of the FD Manager I'm going to manipulate in my on create code here. So let's look at that code. And here we go. In the form create, I'm setting the backup folder to the executable directory and then a directory called backup under it. And I said I want the backup to have an extension called back. Now here's an interesting thing. That backup folder, I'd like to know what exactly that folder is. So I'm calling the backup folder, I'm calling the FD expand string function of FireDAC to take that backup folder and expand it to the actual physical file location. So what that'll do is cause the substitution variable to be expanded to whatever it refers to. And I'm asking if that backup folder doesn't exist, then I'm going to force the creation of that backup folder. Furthermore, I'm saying that the default store folder is also the run folder, not the run backup folder, and the default store format is the store format of XML. That I want backups to be created, I use the FD memtable's FD bottom resource options and set backup to true, the persistent file name to clients.xml, and persistent I set to true, and that'll create the automatic creation and destruction. Now what I'm doing here is I'm saying, hey, if that persistent file name does not exist, then I'm going to create the structure, the initial structure of the FD mem table. And I finalize that by calling create dataset and then opening the dataset. Actually, create dataset opens the dataset. Opening the dataset is what I call to open the dataset, and that will open up clients.xml in this case because the file obviously exists. So let's take a quick peek at the directory so we can see that before we start directory for this project, and I'll show you that initially we have no backup folder and there's no clients.xml project. So come back over here, let's run this project. When the project runs, it's going to open this data set that's created for the first time. We go over here, notice no clients because it's not going to be created until we actually save. So let's add some data, and I'll create a couple names here and a couple. I'm not going to fill out the rest of this stuff. Now I'm going to close this, and there's the client XML that's just been created. Notice if we go into the backup directory, there's nothing backed up yet. And I did force that directory. I created that directory when this ran. Now, in code by doing the, where is it, right here, directories, just force directories, that's where I created it. Let's go ahead and run again. In this case, it's not going to create the file, it's going to open it. And it does it automatically. Well, there's the file there. I called open and it went and loaded that file. Let me make a change to this. We'll add another record. Let's even make it more interesting. I'll delete this second record. Now I'm going to close, and if we go to the backup directory, clients.back, so it actually persisted a previous view of that record, or that data set, a previous image of that data set. And I've got a button here that'll go to that data set and show me what I have. That was before I edited and added Carl and removed Bob. That is my backup. And this is the current version of the file. So this is a fun little thing. There's precious little data in here, or code. Showing backup has the code that just says, okay, let's go and open up another form and load data from that backup file. And this here, I'm just, when the form is closing, if I have any data that is currently hasn't been posted, I'm going to post it before we close. And there, that's something to play with. Thank you for joining my session today. On this slide you'll find the URL for my website and my email address, as well as my blog and my LinkedIn account. If you'd like to link in with me, send me a message and mention CodeRage. Also, I invite you to follow me on Twitter. My Twitter handle is @Cary Jensen. Finally, you'll see URLs for my two latest books, Delphi In-Depth FireDAC and Delphi In-Depth Client Datasets. At these URLs, you will find links to buy these books in hard copy and in PDF format. Once again, thank you for joining me, and have a great day.